Professor Bob Young here, and we're actually going to get to some graphing now of these rational functions or fractional polynomial graphs. So here we go. Hold on. Now, we have been looking in your supplemental handouts here that you can get in Angel or were given to you in class, and it's entitled Graphing Rational Functions, and we've talked about and discussed finding the asymptotes and so forth. So, ladies and gentlemen, it is time now to go on here, and there is the rest of that supplemental handout. So we have talked about this, the steps for graphing functions. One, find all the x and y intercepts, which sometimes is great and other times I don't really know if I go for. Two, I really go for, always get those asymptotes, the va, ha, and sa, which they call the oblique or slant asymptote. The point at which the graph intersects the non-vertical asymptote, now that would be the ha or va they're talking about in step 3, if there is any such point. That kind of helps you out sometimes. And the behavior of the function on each domain interval determined by the vertical asymptotes and x-intercepts. All right, so let's go ahead here and look at some other items here. So this is, again, a recap on what we're going to be doing, finding the vertical asymptotes, horizontal or oblique, the y-intercept, x-intercept, any point that would cross one of the horizontal or slant. So we're just kind of running through steps here, but I am starting to itch to get to some graphing. I don't know about you. Plot selected points is necessary and sketch the graph. So as promised, here we go. I'm going to go ahead and start out with graph this function y equals 4 over x minus 2. And the first thing we're going to do, what number or numbers make this denominator 0? That would be the va. So what hopefully you would see x equals 2 would make that 0. Now, if not, you could, of course, take this denominator, set it equal to 0, and solve for x, a very basic equation there. So once we get that, we're going to come over here and graph this rational function. So I'm going to go ahead and put the va, or vertical asymptote, here. And you might even hum a few bars of that Hammer song at this point. Can't touch this. Can't touch this. It'll never touch or cross that asymptote. So keep that in mind. The horizontal asymptote we've talked about in other videos. Notice this top degree, x is to the first power here. There is no x in the numerator, so the top degree is smaller than the bottom degree. And do you remember what that means? The va is y equals 0 here. So if you wanted to, you could put a little dotted line, and I think I'll do this in red, across the x-axis. Now notice what I did next is I went ahead and I took some points to the left and right of the va here. So I went ahead and I saw that this va is x equals 2. So I went ahead and I went to the left and right of the va. So I went and I plotted, well, what is when x equals 1 here? When x is 1, y is negative 4. When x is 0, y is negative 2. When x is negative 1, you get about negative 1 1/3. So again, with my writing tablet here, I'm trying to get these as close as I can. Negative 2, negative 1. And you can see the hooking action on this here. Now, since y equals 0, will anything ever cross the va? Will it touch the va? Because, like I said, the vertical asymptote, the graph will never cross or touch. The horizontal, it may. So knowing that the vertical asymptote is y equals 0, if we plug 0 in here for f of x, and we try to solve that, let's do it. 0 equals 4 over x minus 2. If you can get a point here for x, that's where it will cross that horizontal asymptote. But since this top number is always a 4, there is no number that will solve this equation. I mean, in order for that to be 0, there would have to be something in the numerator that would come out 0, and it's not going to happen. So this graph will not ever cross the va. but we will see examples where there might be places when graphs that will cross it. All right, now let's go ahead and connect the dots here. So again, I like to call this the hooking and hugging action here. And with my writing tablet, it's going to be a little difficult here because it's slippery, but that's kind of really close. Now, again, I'm not touching or crossing the vertical or horizontal asymptote. So now let's go ahead to the right side of this vertical asymptote, and I'm going to plot the point 3, 4, 4, 2, 5, 1 1/3. Now you could use your calculators and get these points as well, and 6, 1. So all I'm doing here is if I say what is f of 6 up top here, okay, if I'm just plugging in 6 wherever I see an x, I'm going to get 4 over 6 minus 2, which is 4 over 4, which is 1. So just plugging in 6 for x gives me 1 for y. So I'm just getting these points left and right of that vertical asymptote. And here is our first graph of a rational function. So that is what they tend to look like on the ends. They have this hooking and hugging action, as I call it. I like to call these the hooks when you graph these things. All right, now there's only one graph better than just having one vertical asymptote, and that is a graph having more than one. So notice this one. If we have this next graph we're going to look at, we can factor this denominator here and get 2x minus 1 times x plus 3 factoring, and we could, of course, check that by foiling. Setting each one of these equal to 0, we're going to get the vertical asymptotes at 1/2 and negative 3. All right, so that will be the vase here when we look at this graph. Now again, as shown before, the horizontal asymptote is going to be the x-axis, or y equals 0. Now why is that? Notice this top power here, x to the first power, is less than this bottom degree or power, which is a square, so that always is going to happen in step 2 when you have a top degree less than the bottom. And then we'll go ahead and we'll find the y-intercept on this one. So letting all of the x's be 0, we get the y-intercept is negative 1/3. And if you want to write that as an ordered pair here, we could say 0, negative 1/3. Okay. And then we can get the x-intercepts by letting y or f of x equal 0. So if we go ahead and we plug 0 in here for y, they do it in blue down here on the bottom. Notice it says if a rational expression is equal to 0, then its numerator must equal 0. So setting the top equal to 0, x plus 1 equals 0 here. Solving for x, we get negative 1 is the x-intercept, or we could put negative 1, 0. Okay. Now, step 5, it says, let's determine whether the graph intersects this ha or not. So if we let this function equal 0 here, we already found that up top here. So if we put 0 in here for x, we know that it's going to come out negative 1 will make this top 0. So the graph is going to intersect the ha at that point. So when you find the horizontal asymptote, if you let the function equal that value and solve for x, you'll be able to find the point at which it crosses the horizontal asymptote. Now remember, never crosses or touches the vertical, only the horizontal. So now we're going to plot some points here in the intervals determined by the x-intercepts and the vertical asymptotes. So we're going to take some points left and right of the VA, get an idea of how the graph behaves and stuff. And here is what it's going to look like. Now notice, since I have two vertical asymptotes here, I've got x equals negative 3 and x equals 1/2. I took some points to the left of negative 3. I took some points to the right of the 1/2. So I'll put that here, left of negative 3. And then I took some points between the two and here. And if you plot those, you're going to see this graph. And usually when you have two vertical asymptotes, ladies and gentlemen, you are going to have an S-shaped creature here in the middle, or sometimes in the middle, you'll get a parabola-looking thing like this. So usually when you have two, you're either going to get an S-shaped creature or some kind of parabola when you plot those middle points here. And notice that at -1, 0, the ha is being crossed here, okay, by what we did previously. All right, now let's try one more example here. I try to give you plenty of examples and looks and so forth. So we're going to look at this graph next. The equation of the vertical asymptote, what makes the bottom 0 is x equals 3. So we'll come over here and put va x equals 3. Notice this one, the top degree is equal to the bottom degree. So you take those numbers in the front, the coefficients, whenever this happens, so the coefficients in front of the x's is 2 over 1. So the ha would be y equals 2 over 1, or 2. And we've talked about this in other videos and lessons and so forth. So again, getting those is very important. All right, letting x be 0 here, we're going to get, and this is very easy to see here, because if you plug 0 in for x, that goes to 0, that goes to 0, and you're left with y-intercept of -1/3, which we'll write like this, 0, -1/3. Now we're going to let y equal 0 and solve for x to get the other intercept here. So this is how we've done this in many graphing things we've done to get the intercepts. Now notice here again it says if a rational expression is equal to 0, then its numerator or top must equal 0. So we'll just take this 2x plus 1, set it equal to 0. The x-intercept is -1/2 0. Okay. Now, let's go on here. Will this graph cross or touch the ha? Well, since we know that the ha is 2, because we said that's the coefficients here, if we take and set this function equal to 2, which is the ha, if we go to solve this for x by multiplying by the LCD, we're going to get 2 times x minus 3 equals 2x plus 1. The x minus 3's on the right would cancel out. Now, of course, I could show that step in color a little bit better here. Distribute. You can have fun and hum when you do this. Notice the x's will cancel out, and you will be left with a false statement. So there is no solution when this happens, so the horizontal asymptote will not get crossed in this case. So graphing it again, I went ahead and I showed that the ha was 3 there, x equals 3. The vertical or va is x equals 3. And the ha, or horizontal, is y equal 2. And again, I took some points to the left of the va and to the right of the va, and then you can see the graph. So when there's only one vertical asymptote, you usually just have the hooks on the ends there. All right, now we're getting to some really scary ones. These are the scariest of the scary. So notice again, this one will factor, and we can say we're going to have more than one va here. That's when they get the best here. X plus plus, but we'll factor this one, 4, 4. Now this one's going to have the same va. It's going to be -4, although it factored into two different things here. Has two different factors, but it still just produces one vertical asymptote here. It says since the numerator is not 0 when x equals -4, the vertical asymptote has the equation x equals -4, because you always have to make sure of that. we divide all terms by x squared to get the equation of the horizontal asymptote. Now notice here the top and bottom degrees are the same, so those coefficients in front, 3 over 1, will give us our If you can graph some of these, you can graph any of them. Now the y-intercept is going to be, if you let y be 0 and solve for x here, or I'm sorry, the y-intercept, if you let all the x's be 0, watch what happens here. That goes to 0, that goes to 0, that goes to 0, this goes to 0, and you're left with this fraction, negative 6 over 16. So when x is 0, y is negative 3/8. It reduces to that. Now make sure you always reduce your fraction. So there's the y-intercept. So we're just going through this in the same steps here. To find the x-intercepts, we're going to let y be 0. So we're going to set that numerator here equal to 0. So we'll find the other intercepts, which is always a good graphing tool. And notice this one's going to have two x-intercepts at negative 1 and 2. So we're just finding all kinds of pieces of this graph. Okay. Now, step 5, will this graph cross the ha? Now, we know the ha is equal to 3. We just found that out. So we're taking this whole function here, and we are going to set it equal to the ha, which is 3, to determine if there are any places where this thing's going to cross. Now, notice here we're multiplying by the LCD down here on the bottom. And then we end up getting 3x squared minus 3x minus 6 equals 3x squared plus 24x plus 48. And solving for x, we do have a place, x equals negative 2 here, where it is going to cross the ha. All right, so the graph is going to cross the ha at this point, negative 2, 3. And we will see that as we continue here. And lo and behold, here it is, ladies and gentlemen, on this one here. So we only had one va here, and there it is, x equals negative 4. Took some points to the left of that, got this part of the graph. And notice here with these big numbers, 84, 30, 18, we would really have to use our imagination and extend that. I mean, that thing, when it gets to negative 5 here, negative 584, do you see, would be way, way up there. So this line is projected to eventually go through that, but never cross or touch the va. And then I took some points here to the right of the va here, and noticed as promised at negative 2, 3, that's where it's going to cross that horizontal asymptote. And this one even dips below the x-axis and comes back up here, as you can see. So you want to take enough points to the left and right to see the graph as it comes back and approaches the horizontal asymptote. All right, so that concludes our graphing. I think we've graphed a lot of things. We're going to graph some more things in the next video. So come back. Professor Bob Young signing off.